Right. Barry, thank you so much. Thanks for the warm welcome. Hi, everyone. It's great to see everybody on Zoom. I can't wait to see all of you in the conference coming up very, very soon. And I am absolutely thrilled to actually represent a community of lab professionals. A few years ago, before pandemic, we started gathering in the conference. Um, and like-minded people who have a large amount of face time with students. We are sometimes eyes and ears for the departments. We do all the planning for the labs and occasionally teach. I thought it was a great way to congregate and meet in the conferences. And so we had a group. Our community became actually much stronger in the pandemic, and we kept on meeting up. And thanks to Isida, we have formed a great community of folks who are able to navigate our way through pandemic. And now I think even we are better. I think we got ideas, we crowdsourced all the possible new ways of doing things. And if you heard yesterday, there was a fantastic discussion. If you missed it, please take a moment and see when the recording is up. The discussion about what's actually happening when we used to think about flipped. Now everything was flipped when pandemic happened. And somehow we found, I think, a way to re-energize the hands-on learning. That was my take through pandemic, that I think it became more organized. The flip became, I heard this term, high flex, hybrid and flexible, where we have a way to create a platform to make sure that everyone engages with the hands-on education really, really well. So the conference, during the conference, we have 5 sessions planned to give you a preview, and all of that information is on the website. But those are 90-minute sessions with folks participating from many universities. We have panelists. And typically what we do is we have panelists who will speak for a few minutes, maybe 5 or 7 minutes each, and then we are open for discussion. So let me give you a glimpse of those 5 sessions. Our first session is going to be Autonomy, Controls, and Robotics in ECE curriculum, where people are going to come up with ideas of their model curriculum that includes aspects of autonomy and robotics in their curriculum. The second session is on maker spaces, and this could be a recap of a maker space workshop that's happening on the Friday of the conference. But we have a panel of folks really passionate about presence of maker spaces in the curriculum. The third session is increasing student engagement. And we are not just grown-ups talking during that panel. We're actually getting students from universities to come, fly, be in the conference, and they, our stakeholders, are going to tell the folks what they feel about the curriculum, the great parts of it, not so great parts of it, things that they were looking forward to, expectations. So I'm expecting that to be very exciting, okay, having students on the panel. The fourth one is also student focused, but the idea is have to foster innovation among students with student clubs. And we have seen this. I've seen this in my several years at Penn, that students clubs can do innovation not through semesters but through years. So we have Penn Apps, which is an annual hacking competition. We have Penn Electric Racing that builds new electric car every year, and they're completely done without adult supervision. They're all student driven, and that's where the energy is. And I think a lot of innovation and excitement comes from those opportunities. So I'm hoping to have a panel of folks who will bring in their ideas of how they were successful in building great student communities. And the last one is about senior design. the capstone, as we call it, typically a 2-semester course offering in the final year. And if you are from a university, you most likely know that the senior design is where sometimes we can put our best feet forward. Some treat it as a checkbox, some treat it as an ambitious, innovative project. But I think overall, I would love to see, like many who have said in the lab professional community, the senior design to be elevated. So it's going to be a discussion, suggestions welcome, and we are going to have a conversation about what can we do to make it the most sought after course, not just a checkbox in the engineering curriculum. So that's the preview of the conference coming up, and we timed this technology professionals meetups at the same time around when there is ECE Expo also going on during ECEDA conference. So there's a lot of excitement in that conference. We would love to see you there, and if folks want to participate, even as panelists or speakers, please let us know. This has been always a very informal conversational community. So I look forward to everybody's participation. So for today, we couldn't have had better panelists. I almost think that the panelists we have kind of reflect the kind of things we would love to see being discussed at those sessions. So Sydney, if you don't mind, put the next slide, please. Oh, there you go. Okay. And so we have, Ray from Altium, Sean from Edge Impulse, Bob from Pico Technologies, Greg from Rodian Schwartz, and they kind of represent, as I see, parts of our curriculum. Students love to dip in everything, and I think having a focus helps. If you heard yesterday's talk, there are people talking about threaded curriculum, in which a lot of courses have a crosstalk. But I also think that we need to keep up with what's out there. We need to innovate. We need to be agile in our curriculum. And so this is a great panel where we're going to have some discussion about future directions, what are great ways to expand on areas that we know could use certainly some more scale. And so I'm going to start with each one of them introducing themselves. Maybe they have a slide to show a brief summary of their background, but then after the introductions, we're going to open the floor for Q&A. So it's going to be very informal, and I look forward to it. All right, so Ray, if you don't mind, we'll kick it off with you. Thank you, Ray.
Great, thanks so much for having me. I really appreciate that, Sid. Nice to be here this morning. So yeah, my name is Ray Callander, and I'm Vice President of Education for Altium. And it's really, in short, and we'll get into this in the discussion, but in short, we look forward to our education really wants to attract talent to the world of electronics. And we, in that effort, we want to support the next generation of electronics designers with free curriculum and tools and professional tools to really help them prepare for their careers in the future. I'll say briefly that last year we launched a program into high schools and very quickly got up to 7,500 students globally that took our curriculum and learned about printed circuit board design. And I will share what we are about to launch right now, which is Altium Education. So this is free curriculum that allows free college level curriculum that allows college students to learn printed circuit board design and master the basics of PCB electronics and ECAD software. So we're very excited about it. This is really a sneak preview because we're launching February 23rd, but the students will be able to come here, enroll for free, learn online, explore ECAD concepts, and get certified. So we have a course really that teaches students who know nothing about printed circuit board design, like ground zero, to being able to manufacture their own board. So we have the introduction to PCB design, schematics and libraries, PCB layout, routing and basic signal integrity, and then PCB manufacturing, and then a project that they can work on. Additionally, the students get a free license to Altium Designer. So if you're a university student, you get a free license to Altium Designer with this curriculum. And it teaches you along the way. If we go into the curriculum really fast, I know I don't have much time, but I'll just show you a couple of things. So again, we start off really simple and basic, introduction to important terminology. What is a printed circuit board? PCB design, the role of CAD tools, schematics and sheets, so rich content. And then I'll take you also into another section of it to show you a little more of what we've got here. So selecting components, for example, we've got finding components, and then a video, several videos throughout the curriculum that teaches you how to use Altium Designer. Altium Designer, of course, is very complex, but by the time the students get through the curriculum, they will know how to use Altium Designer. So we're really excited about this. And I'll show you a couple other features of the website. We have an educator's guide that takes professors through how to implement this into your classroom, some classes that perhaps this could be used in. And what's really important is that we've set it up in units so that you can assign the entire course, or just grab one of the units and plug it into the course that you're currently teaching. And so we're meant to really fill the gap and be supplemental. We're not displacing anything, we're just supplemental. So, and then there's an About Us section as well that talks about Altium Education, our high school program, and then the several hundred student teams that Altium supports. So with that, I think that's my introduction, and I can answer questions as we get into it. But I'd love for all of you to take a look at our website. We can get this out to you once we launch on February 23rd. Thank you so much.
Great, that was awesome. Thanks for showing it off and making this a launch place to disclose it. We love this. Thank you.
Thank you for having me.
Yeah, I don't know the order, but can I go by what I see on the Zoom screen of introduction? So if I don't mind, Greg, would you mind introducing?
Absolutely. Good to be here, Sid. Good to see everybody. My name is Greg McCaskill. I'm based here in Austin, Texas, a new up-and-coming tech hub, as you all know. And I'm a product manager for Rohde & Schwartz, and an electrical engineer and a graduate of UT here in Austin. So it's fun to be here working with the CETA, and we've come for a few years now, so it's nice to be on the panel as well. Thank you, Sid. Thank you, Kim. So Rohde & Schwartz, if you're not aware of us, we're probably the biggest test and measurement company you're not aware of then. But we support and sell RF test and measurement equipment. And I tell you what, I can give you kind of just a snapshot into what that looks like perhaps for education. So if you take, for example, just our spectrum analyzer portfolio, the investments we make in a portfolio such as this, we have kind of a unified GUI and analysis capability. So all of our platforms look similar, and they're going to have the same types of functionality. Of course, as you go higher in performance, you have additional capabilities. But this instrument here on the top left is an instrument we sell into education, and that has the same level of quality and technology as the rest of our portfolio. So really, one of the ways we like working with education is bringing the same experience, the user experience, measurement capabilities to students. And I have some information in the breakout session on tools specifically we've created for this instrument around education, a device, and some lab materials and user guides and things like that. So, but that's how we interact with universities. We do currently about 2.3 billion euros a year in test and measurement in this field. It's a huge growing market, and there are significant challenges. As you know, technology moves quickly, so engineers are faced with a lot of new challenges every year. So yeah, looking forward to this exchange.
Greg, thank you so much, and thanks for coming and coming to this panel. Really appreciate it. Sean, if you don't mind, you want to introduce yourself, Edge Impulse, and again, for those of you who've not heard of Edge Impulse, great startup. Sean, go ahead.
Yeah, thank you, Sid. My name is Sean Hemel. I used to work for SparkFun Electronics. That's where that image when you were introducing all of us came from. I think that was my first or second video at SparkFun I ever did. So I had a few less gray hairs in that one. And I've been working with I worked with SparkFun to do a lot of their educational material, whether it was free videos online, as well as I've been to ACETA, ASEE, and all of these to support their university efforts. And I've recently joined Edge Impulse to help support their education efforts as well as creating content to educate existing engineers and hopefully assist schools, universities to use machine learning on embedded systems. So if I can drive my screen real quick here, I will give you a 3-second view of kind of what Edge Impulse looks like if you're not familiar. And hopefully we can see this one. So Edge Impulse is a machine learning framework. It's an online tool where it allows you to collect data. And as you can see here, I'm collecting accelerometer, 3-axis accelerometer data. I can create what we call an impulse, which is a combination of a signal processing block that feeds into a machine learning block. And it will walk you through the training process. If you're familiar with neural networks, you can see I've created a very basic dense neural network here. I've already trained this one, and you can kind of get an idea of how these groupings look from the accelerometer data. And it helps me classify what those motions were based on that data. From there, we can go into deployment, and we have a number of supported boards, including Arduino, and you can download a C++ library to put into any build system that you like. This wraps up all of this code into a local, what we call an impulse, a combination of digital signal processing, machine learning for inference, and that can be run locally on your embedded system. I'm going to stop sharing there. So we can talk more about that if you have questions for me in the breakout session, or just what the future of embedded machine learning looks like. It doesn't have to be specific to Edge Impulse. So I will give it back to you, Sid.
Thank you, Sean. Great, quick introduction. Wonderful. Many of us are new to this, so I'm glad you came to show this off. Bob, if you don't mind introducing yourself. Thanks for coming, Bob. That was great.
Certainly. Thank you, Sid. My name is Bob Baker. I am the Sales and Distributor Manager for North America for Pico Technology. Pico Technology is a manufacturer of test and measurement equipment that got its start in 1991. We're based out of Cambridge, England. So we've been in business of building high quality test and measurements products for 30 continuous years. Our products have gained a lot of acceptance, much acceptance in education over the last couple of years, especially because of COVID and remote learning, and across the board in upper level science and technology programs. Our goal is to help you, the educator, help successfully and cost effectively prepare the students for electronics and engineering careers, whether that is instruction and lab work conducted in the classroom or remotely. Today in the executive suite, we'll share our product. This is a product that is sold, it's our largest selling product for education purposes. It's our 2000 series scope. It's a real-time oscilloscope, and it has a great price point and has been very effective for remote learners, allowing them to spend, not being tied to a specific timeline in the lab. They're able to use it whenever they want at home, and maybe help them have a deeper understanding and deeper learning of the product and how to use it. We'll share more in the executive suite. And thank you, Asita and the team, for inviting us to be on the panel.
Thank you, Bob.
You're welcome.
Appreciate it. And by the way, chat's open for Q&A. You know, feel free to put the Q&A on the chat. Bob, since you're warmed up already, since you gave the last introduction, can I ask a question about things that I know I was waiting to get my hands on? If you don't mind, I can start with you.
Certainly.
What we saw in pandemic was this urgent need to provide access to the lab since the labs are closed. Okay, it came almost overnight. We had summer to think about it, but we actually thought that after the summer it'll be all okay, and then it didn't, and we decided to go, online. How has it been? I mean, what's your take on how students and the universities that you might have been in contact with received this change from brick and mortar labs to taking labs with you? Do you have any firsthand experiences?
You know, I do, just from some of the students, some of the faculty members that we've engaged with. But I think the bottom line is our product has been able to allow students to work at their own time, at their own convenience. As I'd mentioned, I do think we've had some comments from faculty and students that feel that the students are able to not worry about a 1 hour, or maybe you have a professor that likes you and gives you a couple of hours in the lab. They can work with the oscilloscope on the weekends. They can try their own experiments as well as whatever they're following in the lab. And I have to tell you, the price point, when it's cheaper than your calculator that you have to buy or the digital textbook, it makes a big difference that not only are you going to use this through the course of your educational requirements, but you're able to bring it out in the real world into your job. So I think those have been huge upsides right now.
Yeah, and I think that's what we saw, Bob, even within maybe 100 students or 150 students who are doing lab courses in a semester, we felt the same comfort that students had, that they had stuff with them, okay? But there was always this feeling that we were not ready to create at that time a curriculum that would reflect at-home labs. We are still used to this separation of lab and a class, which now all became on a one platform. Like everybody's home, everybody's doing things in the same way. So I think we are
Right.
adjusting as educators. We are adjusting to this way of combining all the content, or a singular way of doing things. But that's true. Greg, if you don't mind, if I would ask you a question, which is a common question asked by folks who have been in the lab world forever, which is students need to know instruments when they go to industry. It's kind of an engineer's cookbook that they need to have mastered before they start a job.
Right.
And frankly, I'm struggling with a transition from very personalized laptop-based instrumentation to stuff that's outside the laptop. It's on a screen that's specialized.
Right.
Any suggestions from your perspective on how we make that transition? And we know how critical it is for them to get there, but we need a pathway.
Right. Yeah, I think that's a great question, Sid. And I think the nature of this panel really illustrates how important education is in this transition. Brody Schwartz, of course, is in the business of selling boxes, right? Instruments, test and measurement boxes. But one of the main ways that we reach and support customers is through educational materials. And over time, that's been white papers that evolved into shorter content around app cards, that are consumed more quickly. And in the past couple of years, we've done a lot around YouTube and lengthy webinars. Again, this is because customers come to us for this. We're not trying to get into the business of being an educator. But one of the big and surprising trends that we see again and again, and I think this is the nature of how much these instruments do. For example, if you think about an oscilloscope or a spectrum analyzer, if you go and download the user manual, any guesses on how many pages there might be in that user manual? It's usually about 1,000 pages. So and that's just one instrument in a lab. If it's an RF lab, you probably have a power meter, a power supply, a spectrum analyzer, a VNA, a signal generator. Wow. Okay, that's a lot of user manuals, right? So the modern world is definitely turning to consumable education that they can find on the job. And so back to what really surprised us when we created content around fundamentals. If you think about a scope usually has 8 or 10 or 12 different types of triggers. We all think of triggers when we think of a scope. It's the main thing it does is it somehow captures an event. Our customers know the edge trigger, and there was very little understanding beyond the edge, getting past the edge. So fundamentals has been a huge market. We see tens of thousands of people consume our fundamental coursework. And so if I was going to start anywhere or throw an idea out, it would be to make sure the fundamentals are there around what do these instruments do? What does the measurement mean? I've got something on the screen. Is it right? What are the basic settings of these instruments? So that's one of the trends we're seeing, even in industry, as engineers are reaching out to us. It's the question that they're afraid to ask, their boss or something, and we're answering that. And we're happy to answer it, but I think it would be very valuable for students coming out to have a solid understanding of the fundamentals.
Yeah, and I think I just want to comment and then ask this question to Ray, but you'll be surprised after students used a USB connected scope for a whole semester. When they're coming back to lab this semester, they're actually more excited and better educated to use a regular scope because they've actually had more time on their scope than they ever had before, because this was with them and they could use it for 4 hours at night that we never could provide. So I think there is a space for both, instrumentation that's appreciated because it's better, and that it's backpack instrumentation that is more personalized, that is with them. And I think there will be a space for both, I think, as we all adjust. But Ray, I have a question about, the ultimate things that ECE wants to build. Okay, so there are folks who build the software and there are folks who build the hardware, and now there are these folks who are trying to put very sophisticated SoCs on PCBs, and they are doing firmware on a PCB. Then we are seeing, we had experimented with one class, it's called Design for Manufacturing IoT, where we tried to do firmware and PCB, and boy, it's a big hit. Okay, and so we think it's a very expensive proposition to get there, to get all these PCBs manufactured. But we would love to see, what you did with Altium Education. Take a form that the lab community can really benefit. So we would love to hear from you, plans and support that Altium might, bring in, or the way we can expand our portfolio for hands-on building things.
Okay, sure. Yeah, so with Altium Education, we are teaching students how to create printed circuit boards and then taking it to actually manufacture the printed circuit board. So I think as part of your question is, how do they get that manufactured? And Altium has a manufacturing unit called Autonomy, so you can actually create the printed circuit board. So they can create that. But this is, our education and our, Altium Education really is for hands-on learning. It does teach students how to create printed circuit boards. It is really a lab, it can be used. Again, we set it up with educators giving us the advice that don't just, paint us into a box and say, assign this course. Put it into units so we can grab, the introduction to printed circuit boards. That would be great across many disciplines. And we're finding too that, across many disciplines, students are excited to learn about printed circuit boards. Entrepreneur clubs are excited to learn about how to create a printed circuit board, because they can, if they want to solve a problem, they know enough. Incubators, they know enough to talk to the engineers to get the actual board time. So, that's what we're all about. But we're just really excited to help, the next generation of electronics designers learn this, and we want to fill that gap with a lab that teaches students about printed circuit boards. So I hope I answered your question. But
yeah, no, Ray, that's great. And what a segue to Sean, because I'll tell you the thing that happened after that class, when we started telling people how to do firmware, and it opened up this whole opportunity for people to do things like tiny ML that we never knew could be done. Okay, this whole idea that our ECE students are going to get excited about machine learning on a processor with very little background, after one embedded class. And Sean, you'll be surprised how many, as you probably know, you've been at SparkFin, how many students want a word machine learning on their resume now, right? If every graduating student wants to get their hands and feet in machine learning, deep learning, some measure of AI as part of their portfolio. And part of it is this SoC tools that are available out there. And so when I looked at Edge Impulse, the only time I had read about Edge Impulse is when they had won some Series A funding some time ago. Okay, and we were like, okay, I think it came in some email. But then I see the product, this embedded machine learning, is very, very fascinating. And I'm wondering, what are your thoughts on how to integrate that in the curriculum?
So that is a very fascinating question, Sid. And I guess the idea of machine learning, like you mentioned, is the hot thing right now, right? Every engineering student, every computer science student wants ML, AI on their resume. I'm sure it's, if your school's teaching it as an elective, I'm sure, the waiting list is super long because everyone wants in. And so the idea of, is it something that needs to be integrated into ECE curriculum, or should it stay in computer science realm? And for the longest time, it was just computer science. You could take a machine learning elective, learn about support vector machines, neural networks, whatever. ML topics were popular at the time, up until the last couple of years, when we started to see interest for running these algorithms, these fairly complex algorithms on microcontrollers, or things like your Raspberry Pi or single board computers. But the idea of running it on a microcontroller is frankly kind of bonkers. Like, why would I take this super resource limited device and run a machine learning algorithm on it that takes almost all of its resources? And the other thing is, a lot of times it's non-deterministic. It has a 90-something% chance of being accurate, right? So like, why would I do this? Most embedded engineers that I know, most firmware writers, they hate non-determinism, right? It needs to work 100% of the time. Oftentimes it's mission critical, safety. And for those cases, I would say machine learning is probably not a great application, but we're seeing new things come out, new technologies. Think of your smart speakers, things like predictive maintenance, things like person detection, right? My new doorbell camera can detect people. And a lot of times that's not being done on the web. It's not streaming all this data to the web. It's doing it locally. And you only need to do one thing and one thing well, and that's is there a person in the frame? We don't need a massive machine learning algorithm to do that. We just need it to be good enough, small enough, that'll run on this embedded system. And so we're starting to see use cases of where machine learning is frankly quite useful on embedded systems, especially microcontrollers. And I think that's where we're getting to the point. To me personally, I think machine learning on embedded systems is going to be kind of the new DSP, right? If you remember what DSP looked like in the, what was that, 80s, 90s? I was not in school then, so you'll have to forgive my ignorance. So other people here may remember that, but there was an explosion of, can we run these signal processing algorithms to do filtering, fast Fourier transforms? Can we get special hardware to do these optimized functions to do DSP? And that was the new thing in the 80s and 90s. And when I was in school, a lot of professors specialized it because that was the hotness when they were around learning embedded systems. So to me personally, my bet is that machine learning on embedded systems is going to look a lot like the trajectory of DSP did 20, 30 years ago. And so in that case, I think it is important it start to be taught in ECE. We start to look at hands-on exercises, integrating it into the curriculum. And one of the things I want to chat about in the breakout session, so I'll leave that for there, is this idea of doing it from a bottom up, right? Do you need to know how backprop works from an algorithm perspective? Do you need to take all those CS and math classes to understand these algorithms? Or can you do it from a top-down approach and say, okay, it's a black box. Can we just train a model and it's a black box and we view it as such, but you care more about the data, watching for biases, and you look at things like what are the inference results and probabilistic type of outcomes. Is that what you care about more, or do you care more about your training and your inference algorithm? So I think that's an interesting conversation to be had about how do we teach this, because machine learning is a very broad field and it's also very complicated.
Thanks for the insight, Sean. But my personal experience has been we underestimate students when they're incoming as freshmen. And I think it's partly limited by our own ability to understand things. And I teach this introductory class in freshman fall. It's ESE 111. It's the first class. And so as a final project, people make stuff out of Arduino. And we made, for the first time, things optional for Raspberry Pi. Okay. I said, we have Pis, Pi 4, take it, do something with it. Half the projects were Python. They installed OpenCV on their own. They were using cameras. They were trying to detect people from some things they downloaded, which was a Python code they downloaded. They were tinkering with it. So I think we are holding them back because that's the way I grew up, and everything has to be bottom up, And you were talking about this, and I was talking to one student. How did you figure this whole thing out? Okay, he says, no, I don't need to know everything to figure things out. I just need to know how to put it together. And I think that keeps them very motivated. And another thing I forgot to mention as we were talking about this machine learning is the cloud aspect for them is very important. If you didn't have a cloud in their curriculum, which is the data on this microprocessor or controller has to end up somewhere where they can see it, it suddenly becomes very important to them. I think to them that's very relevant. And I know that was important to them. Like, where is the data after I measure it? Okay, and so Bob, I'm going to ask that question because I know this is something we struggled with when we gave them all these USB instruments, and they were saving it locally. We didn't have a mechanism set up for them to share because they were all away, right? We were all Zooming with everybody, and we struggled to share the data with the class of each other because everybody had it locally. And I'm wondering, is that cloud-driven personalized instrumentation on the horizon?
Oh, it's here. Sid, we released Pico Cloud, not only for our data logger product, but also for our real-time scopes. And you can upload all of that to the cloud. It can be viewed. For example, you could have data loggers set up measuring something, temperature, whatever you'd like to measure on 20 different machines, maybe in an environment that's not perfect for being there and watching it live. You can upload it to the cloud and watch all of that simultaneously. So that is here, and we'll talk a little bit about that in the breakout too. But it's very important, and you can share it too. I think just being able to share it real time in the cloud is important as well.
So and I'm going to ask you that. So whatever they measure goes into the cloud as an option, or it automatically backs up to the cloud?
No, it's an option. You can view it live on your screen, or you can upload it to the cloud, or both.
Yeah.
Yep.
And I think as a trend we saw when we were remote, that would have been just fantastic. I mean, that would have been pedagogically the ideal scenario if I could combine everybody's data and say, here is the general trend, or here's the general characteristics of this device that was being measured, And I think students, I feel, want to go beyond the measurements. I think they want to learn from what they see as a trend. And we have this dream that we will have VNAs for folks that they can use, forever. I mean, they will be able to get so much out of it because we do everything theoretically. And so, Greg, I was going to ask you that question. Is there a possibility where we can make our RF classes, which are very few in a typical curriculum, connect to more simulation and learning based, so they can do a lot more hands off, and then when they use the VNA, they know actually what to look for. And I don't think we've figured it out because everybody has only a few VNAs, right? So it's like you come in a batch of one or two, you rely on a VNA, and then you move on. Any suggestions? Greg, you're muted. Yeah.
I am muted. Thank you. Great question, Sid. And, I think we're seeing something similar to what you're describing already. And it could be that this is a solution for education as well. Some of our customers that have, manufacturing centers here in the US and abroad are driving towards a cloud-based testing so that they can see overall results. And so we have a product called Cloud for Test that aggregates the control and monitoring and measurements of all the instruments. And, the flip side of that is you can have the instrument where you can log into it. So, we're moving down the path of having, the possibility of not having the instrument on your bench, but being able to log into it from anywhere and buy access that way. So that's not something we necessarily considered for education, but it's interesting. We do have solutions for, multi-in-one is the product that we've offered for education and for that entry class space. So it's a spectrum analyzer. It also has a VNA, and it also has an RF signal generator all in one box, the primary instruments, right? So that makes it affordable to have in the lab. So you could do things like, make antenna measurements and matching measurements for your networks, sweep the cables, measure the transmitter. So you could do all of that with one box. But I think both of those are interesting scenarios. I think there's a movement in the cloud, and we're seeing that from our industrial customers, and that could be something that's very relevant for education. And we're also seeing that the instruments in the entry class need to do a lot. They need to have all the capability in one box so that it's affordable, and it also doesn't take up a lot of space on the bench.
Thanks, Greg. And I want to remind the audience here, please feel free to chime in. I mean, I can keep on chatting with the panelists. I love to, as you can see, but I would love to have questions that panelists can answer. And sticking to cloud, Sean, I'm going to ask you this question back to where all the students' interests seem to be converging, is how important data is in their curriculum. And they're trying to find, especially for ECE, a great number of ECE students are also very good in software. It's just part of their training, And so when we say hands-on labs, now we want to expand that hands-on to hands-on everything, hands-on software, hands-on hardware, hands-on, data science. Where could we make a defining line for a lot of students who want to specialize, especially in this edge IoT and edge AI? These are the things that we are being asked. Do you have engineers who can do edge AI? And students kind of try to understand, wait, what is that? We've done embedded and we've done machine learning, but what's all that? And we're struggling to find a balance, where we need to put hardware first. So they should see the hardware board, some board that, let's say, you support, but then it comes with all this software proficiency that would make it exciting. And I think that would be a great ECE flavor, but would love to hear your take.
So you'll have to forgive me on, are you asking about what type of firmware would help with the hands-on, or what type of framework? What type, what are you looking for as
What's
far
the
as
introduction firsthand that would create this segue for students to feel that, yes, they can do edge AI, but I don't want to do from a computer science perspective. I'm going to do it from, the ECE perspective.
Yeah, absolutely. I think there are a number of ways to approach it. And this gets back to our conversation of bottom up versus top down, right? If you come with all that algorithm knowledge coming from the CS math perspective, you can definitely implement your own. You can, open up a Jupyter notebook, install TensorFlow, Keras, and part of TensorFlow is TensorFlow Lite. And they also have a subsection of that called TensorFlow Lite for microcontrollers. So you can train a model, and assuming you use the correct operations that are supported in TensorFlow Lite for microcontrollers, you can go through the process of creating a model file that's just a flat buffer. That represents these opcodes that you can then package and then ship to your microcontroller, and it runs in C++, which is fantastic. So as long as you understand those steps, that's great. So that's kind of coming from I know the machine learning, I'm comfortable in Python, I know TensorFlow / Keras, and you can package it up. In my experience, it's still a nightmare simply because you have to match the versions of all of these different packages, right? It's not just TensorFlow, it's TensorFlow, TensorFlow-like, Keras. You have, what is it, like Roy, flat buffers. There was a number of other ones like your FFT if you're doing any sort of pre-processing. And if these packages the versions don't line up, like everything just breaks. So it's a nightmare. To me, this is where Edge Impulse can really help in a lot of cases where I don't need to know that TensorFlow Keras side. If I know kind of what architecture I'm looking for, I can just create it. And Edge Impulse gives you a number of defaults to work with that, our engineers have found these work the best in these kind of use cases. It captures kind of 80%. And it handles all of that versioning for you. So you just get a C++ library, or if you're working with Arduino, an Arduino library. It's obviously easier on our supported boards, but you can port it to your own platform. So say if you're using a TI platform that's not listed as one of our supported launch pads, then you can port it. I've done it myself. It takes a little bit of effort. You have to know how to like include certain files, enable certain compiler and linker flags, but it works. And I think that takes out some of the guesswork as far as creating your own firmware that will now run this machine learning, at least for us, inference right now. Maybe one day we'll get to training on embedded systems, but for now it's just inference. And I think that's a good start to get people interested, especially if you use, say, a supported platform from Edge Impulse. You don't need to know all of this super extra firmware knowledge. So when I was doing it, I had to know how to do a DMA or an RTOS in order to capture data to meet my timing requirements, that I can fill the buffers fast enough to feed my pre-processing and inference. So I need to know all this, fairly intermediate advanced firmware embedded system development to do this. But with something like Edge Impulse, a lot of that's handled for you. So you can just worry about, how do I deal with the output of inference? So I think there are a number of ways to approach it. You could probably give Edge Impulse and a supported board to freshmen, and they could start playing with this stuff pretty simply. If you want to know more advanced stuff, or if you want to implement more advanced stuff, you kind of have to know, like, what is DMA? How do I manipulate registers? Or how do I, work with an RTOS? So it's a varying degrees of how much firmware expertise you want somebody to have to introduce them to these concepts of embedded machine learning. I hope that helps answer your question.
Yeah. No, Sean, giving it to freshmen may be ambitious. Okay?
Yeah, sure.
I love the enthusiasm. But what I can tell you is freshmen want to build stuff. They did engineering, they've come to engineering, they've chosen engineering, and we want them to just build something. And Ray, something that always comes to my mind, they build circuits on a proto board and they love it, okay? And then they want to solder a hobby kit, okay, which they buy from Amazon, and they solder. And they do it because they are engineers and they like to do it. Somehow, as you probably know, universities have not integrated PCB as curriculum. People do it as part of hobby, people do it as part of senior design, people do it if they're interested. But I think that is more in PCB design than PCB. And I would love to hear from you, where is the correct pathway to, embracing it? Because I think we want to do it, but we want to do it in a way from a very design-centric perspective.
Mm-hmm. Yeah, I think, PCBs, there's art, science, and technology. And it's a beautiful piece of art, really. And it marries all those. And so, our curriculum is meant to really, and we've heard out there that a lot of universities don't teach printed circuit board design. And it's kind of like a trade, it's a trade within the engineering field. And it could be multidiscipline. Mechanical engineers, electrical engineers, could learn about printed circuit board design. And if they do, and they learn, Altium Designer or another, our curriculum points to our tool, but it does teach you how to create a printed circuit board. And that could be applicable to our competitors too. But if they learn about how to create a printed circuit board and have that on their resume, that they have a leg up when they walk out into the real world, into to go get a job. So we're really excited about that. We love to support the next generation of electronics designers, but what's really cool too is students that never thought they'd learn about printed circuit boards. We try to lead them into it because we do want to attract talent from all walks of life, all genders, economic status, whatever. And the entrepreneur clubs and that sort of thing, they start learning about printed circuit boards, and it just sparks this interest, and bam, they're off on a new path. So we've seen that time and time again. So we're really hoping that our curriculum can be useful to universities and professors and anybody that would like to see, our website or use this in their classroom. Just let me know. I'll put my email in the chat.
Yeah, and Ray, just to ask a follow-up question, because I know you showed us the website. Are these the only sessions that we are thinking in terms of Altium Education? Will there be more coming through?
We're going to be adding, yes, we're going to be adding more training along with printed circuit boards and other things that students need to learn in and around printed circuit boards. We'll be adding that, and we're partnering with other corporations to do that. So we will definitely add that. And we have a whole, professional training department as well that teaches about printed circuit boards. So yeah, there'll be more to come. This is just the intro. Yeah.
Thanks.
Yeah, just to piggyback on that, if I may.
Oh, this is Chris Jennings. He's our head of global training.
You start talking about professional training, I can't help it. No, I've been an engineer longer than I would like to admit. I did see the advent of FPGAs and ASICs, and one of the comments that I had about college, when I first went to college, I never considered going into PCB layout. It was just not something that was part of my realm of reality, in part because the tools were laying tape on Mylar. But the reality is now with Altium Designer, as well as other tools, obviously, it's very approachable. And Ray has been spearheading trying to get this into the college and universities. From my perspective, I think every EE, every robotics engineer, anyone related to hardware at all should have a basic understanding of how to do schematic capture and design. Even if they don't do it full time, the hobby market, the hobby opportunities are incredible, but also the entrepreneur, the inventiveness is there. And the comment I really wanted to make is, when I was growing up, Radio Shack was everywhere. You could get components, in your local store, and you could wire them up by hand because it was possible. Now, everything's surface mount, stupid fine pitch. And at some point, we become our own worst enemy. And so to be able to give students the ability to create PC boards and get them fabbed quickly and assembled potentially quickly. I mean, behind me, you can see I have enough toys that I can get away with doing a lot of stuff, but that's not the case for most, college students. And to enable them to go through the process and to use the Ultimate to get a board fabbed means that they can realize things that just 20 years ago would have been impossible for anybody but a very large corporation. I mean, I can get PC boards turned around in a week. That's insane. But that gives the opportunity for those builders, those creators, to take and advance their understanding, machine learning, artificial intelligence. One of the struggles that I'm seeing right now with those endeavors is hardware. You can't get hardware to run this stuff on. And that's why I was listening earlier, and I apologize, I don't remember who it was talking about, running on the smaller embedded microprocessors, but I can get a Raspberry Pi. I can't get, the big NVIDIA machine, right? But I can get a Raspberry Pi. I have a couple on the shelf behind me. So that approachability, that accessibility is one of the things that Altium Education wants to do. We want to make creating PCBs accessible for everybody so that when you come out of college, you can say, yeah, I've laid out a board. I've gotten it up and running too. That's the other part. The other half that I haven't heard talked about is creating a board is half the battle. Getting it running is the other half. So, the combination of getting access, accessibility, ease of using the tool, getting it fabbed provides the opportunity now for a college student or students to get real practical hands-on experience debugging. This is a trade that nobody talks about, that you learn on the job, usually the hard way, to be perfectly honest. So I think it's a first step. And Ray and I have talked about a lot of things, that some of which I won't say, but we have plans, and we want to really enable the next generation of engineers. And that's our goal.
Well, that was fantastic words of wisdom, okay? Because I know every university wants to do this. And I can also tell you one of the constraints is if you want to make an advanced PCB made with parts sorted with SMD things on it, like SAM-W25 sorted, fab, they're $500 for 3 pieces to get it all done. And if you're running a class of 50, that adds up. So I think there has been some hesitation in running this very design focused classes by just how expensive they are to run. But I think there is no other way out. I think we need to do this for our students, because this is like all their SOC knowledge, their coding, their debugging will all converge. So great. Barry has come on the Zoom in face. So is this a warning that we are wrapping up, Barry?
You caught my unspoken message there, Sid. Yeah, we've got a couple minutes left, but you'll see Kim there. She's anxious to introduce our corporate suites, but take your last 2 minutes.
Okay. All right. I'm gonna see if there is any questions from the audience. Otherwise, I'm gonna open the floor for panelists for their last thoughts.
Yeah, I do see, Sid, that Ray and Sean have posted some information there. I don't know if you want to call attention to that. It looks like they're offering some ways for people to follow up.
That's awesome, Ray. Thank you so much for.
Yeah, no, sure. Sure. If anybody would like to preview our site, my email's in there. I'm happy to send you the link and all the feedback, because we want this to be the best product, for students, and we'd like people's input. So yeah, happy to send you the link.
Thank you. And thanks, Sean. Thanks for the message. I think there will be a time when people will take all of these very, very seriously, and we take it seriously in terms of design. But I want to have the panelists, if they want to say a few things about anything else that they want to talk about, I'm happy to have folks chime in before we wrap up.
Yeah, I can jump in real quick to wrap up. I just want to say I love the idea of finding more ways to get hands-on. And it's always exciting to see what students do and where they can take the technology. One of the things that drives me personally is I felt that there were a few areas in my education, and I loved all my professors and I learned a lot. But coming out, like, I didn't get hands-on creating PCBs. And so I had to teach myself how to do that, as a professional engineer after school. And I think more of those we can give to the students. I think that enhances the fun, and it allows you to get the actual tactile feel. I think we all know how important it is for students to see and get that experience doing the thing that they're designing and implementing all the concepts that they are learning, in the lectures.
Thanks, Sean. Greg, you were saying something.
Yes, thank you, Sid, and thanks for inviting me to be part of the panel. Really enjoyed it. I think I just want to second the idea of the experience. And I think what we see in industry as engineers are either directly working on test and measurement equipment or getting results from somebody that's worked on the device, tested the device, and they've received the results, is they need to be able to interpret those results and have an appreciation for what's right and wrong and common mistakes. You know, if you had the analogy of observing a car crash, since we've all driven cars, you know, we'd have some understanding of what might have gone wrong, right? So if somebody gives you EDM results of your RF transmitter and something looks funny, you'll know the potential, you know, common mistakes that may have occurred during the testing. So there's experience leads to, you know, good interpretation of the data that engineers are going to see day in and day out of their designs. So I want to second the concept of getting hands-on experience as being valuable.
Thanks, Greg. Appreciate it.
Yeah, I would just say real quick, just to play off Sean, the hands-on experience. There's nothing like creating a printed circuit board, getting it shipped to you, and as Chris said, when it actually is working. You know, we've done a lot of work with students, and when they get that board, it's just a whole new experience. You know, just having it on the screen is one thing, but the actual board that's working in a robot or tool or whatever they've designed is incredible. So, yeah.
Thanks, Ray. Bob, you want to add?
I would only say that, you know, it's interesting, and I'll have Ben Ellis from our tech support team join us in the breakout room. But, you know, in discussing his college career, and he was talking about doing his capstone project. And he said, you know, and this wasn't too long ago for Ben, fairly recently. And he said, I had to do my board 2 times. And he was doing it with a, you know, a small Moat microprocessor, you know, like a 6804 or some old ST processor. If he would have had $169 or $165 2204A, he wouldn't have had to do it a second time. And I think all those hands-on learning, as we're talking about, you know, laying out a board, all these things help that learning curve shorten and be deeper and wider. So I think that's where, you know, some of these products and certainly the other panelists' offerings fit. You can't learn as well unless you can get hands-on and see that real board that got shipped or see your board working. So, yep.
Cool.
The main room now. So we just want to take a moment to thank you all once again for attending. Thank you, Sid, and all the panelists today for a great conversation. And I guess we're really looking forward to seeing everyone in person at the annual conference. The dates are March 24th through the 28th. We'll be in New Orleans. It's going to be just a fantastic program. I think we've confirmed so many speakers, and registrations are coming in now really well. So it'll be a very safe and productive conference, and look forward to having you all there. So if you have any questions for us, please contact any member of our team, and we'll be happy to chat with you. Otherwise, we look forward to seeing everyone in person in a few weeks. Thank you all.
Thanks, everybody. Appreciate all the panelists' time. Really appreciate it. Thank you.
Thank you.